For solving polynomial equations, we need to be able to factor many of these equations. So this example here, this cubic function, we cannot isolate the x on this, so we're going to need to factor this. So to factor, remember, we have to find one factor first, and then we have to break down that polynomial into a quadratic. So I'm going to try, looks like 1 probably won't work, so I'm going to try maybe -2. If I plug -2 in, I get -8 plus 4 plus 16 minus 12. Yeah, that's equal to 0. Okay, so that then represents one factor of this polynomial. So we know that one of the factors must be x plus 2. So to find the other quadratic factor, we're just going to break this down by division. Okay, so we have our coefficients 1, 1, -8, -12. This is going to be -2, so we're going to get -6, -12, remainder of 0. So the quadratic then is x squared minus x minus 6. So factoring that quadratic, we're going to end up two numbers that multiply to -6 and add to -1 are going to be x minus 3, x plus 2. So those are the factors of that quadratic. Equaling 0, which it does ask us to solve, so don't just factor, we need to also actually solve this. We have a double root at -2, so we can write it like that if you like, or you can just leave it as 1. I'm just going to write it as a double root just to indicate that this is we have all three solutions to the cubic function. So there it is. There's my solution to that cubic equation. For this one here, we can try doing the same thing. However, the reason why we factor this, because we couldn't isolate the x. Here we can isolate the x. So we're going to end up with x minus 3 cubed equals -27. Okay, we can undo that by cube rooting. So in this case here, because we can isolate that x by cube rooting, we're just going to solve it in that way. We don't want to bother expanding this and factoring, although that is possible. That's not necessary because we can isolate the x in this case. So we end up with x minus 3. The cube root of -27 is -3. So we can solve for this as x equals 0. Okay, so x equals 0 represents the solution for this equation. Okay. So if we take a look at this one here, we want to solve for x. So to solve for x, we probably want to get these x's out of the denominator. And it's really hard to recognize what type of function are we actually dealing with. Okay, what type of function is this really? This is, well, we don't know. So let's get rid of the denominator here. So we're going to end up with x minus 4. And this becomes x squared y plus xy. Okay, so I need to solve for x. And one thing I should recognize is that this is a quadratic function in terms of x. So how do I solve this? Well, maybe I'll start by making it equal to 0. So I get x squared y plus xy minus x plus 4. Okay. How do I solve this? Well, the y's are actually really distractors. Really, this is a quadratic equation. And I can solve for this quadratic equation if I recognize the coefficients. So I'm just going to write this slightly differently as yx squared plus, I'm going to factor the y minus 1 out, y minus 1x plus 4. Well, these are the coefficients of my quadratic equation, y minus 1, and 4. So I can use my quadratic formula to solve for this. So I get x equals -y minus 1 plus minus y minus 1 squared minus 4 times a, which is y, times c, which is 4. Okay, so this is and make sure to get the denominator over 2a, and again the a value is y. So now I've solved my quadratic equation in terms of x. for x. Now I could simplify this as best I can. This looks like 1 plus 1 minus y plus minus. And working this out, this is y squared minus 2y plus 1 minus 16y. Okay, and then that's all over 2y, and I can simplify this a little bit more. Okay, plus minus, looks like it's y squared minus 18y plus 1 all over 2y, and there's my solution. Okay, so although I can't solve directly for x, I can if I recognize this is in fact a quadratic equation in terms of x, I can put it into the general form and plug it into my quadratic formula. So this one here, this is an equation where I have to solve for x in the exponent. Now I can't isolate this x either because there's an e to the x and a e to the 2x, which I can't combine into one expression. So I have to be able to think of another strategy to do this. And I need to be able to separate that e to the x away somehow. And if I can separate it by multiplication, I can then use the zero property of multiplication. If I have factors equal to 0, each factor can be solved independently. So if I factor this, I end up with e to the x minus 3. Okay, so these are now factors. Okay, this has no solution because that's never equal to 0. Okay, this one does have a solution because I can say e to the x equals 3. If e to the x equals 3, then x is equal to log 3. Okay, so there's my solution to that equation. I can figure that out by separating these parts out by factoring and treating each individual factor as its own equation. Okay, so I can make this equal to 0, this equal to 0, and solve those two equations independently of each other. So same thing can be done here. I need to solve this. I can't isolate the x's here because this x is embedded inside a tan in the exponent, e, sines, everything. So I'm going to at least start by factoring. So maybe as I factor, I can see some common terms factor out. And I have a common factor of 3. I have a common factor of e to the x. Now, because tan can be expressed as sine x over cos x, I also have a common factor of sine. The more factors I have, the better off I am, because I can now treat every single multiplication piece. So this is a factor, okay, this is a factor, and what's left inside the brackets is also a factor. So I'm going to be left with minus, well, that's the only thing that's going to be left in here is e cosine x, like that, is equal to 0. So each of these factors can be solved independently. Okay, so this factor here, there's no solution. This factor here, sine x, okay, this has a solution. When sine x equals 0, okay, x is equal to 0 pi 2 pi dot 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 dot. So what we can say generalize is x is equal to pi n, where n is an element of integers. Okay, so any pi term, I'm going to hit the 0 for that. This one's a little bit more complicated in that I have to try to solve that, and e to the 2x, we can't factor any other terms out. So this one here, we cannot solve this very easily. The best I can do is maybe this, is I can do equals 1 over cos x. And then, well, algebraically solving this is really difficult. Okay, in fact, we can't algebraically solve this. So we're really left with only a few options here. Graph, if we can graph, or we can just guess. Okay, so I can try guessing at this. So I have 2e to the x times cos x equals 1. Well, I think that's going to be a pretty tough guess as well, because we could guess 0. Cos 0 is 1, e to 0 1, but that doesn't equal 1. So if this was actually equal to 3, or if this is equal to 6, we could actually solve this by guessing fairly easy. But at this point, we're stuck. We're going to have to graph this. Okay? So we'll take a look at the graph of that.